मंजिल यूं ही नहीं मिलती, एक जुनून सा दिल में जगाना पड़ता है। मंजिल यूं ही नहीं मिलती, एक जुनून सा दिल में जगाना पड़ता है। मैंने पूछा चिड़िया से जब, मैंने पूछा चिड़िया से जब, कैसे बनता है घोंसला। वो बोली, तिनका तिनका उठाना पड़ता है, तिनका तिनका उठाना पड़ता है। तो डियर स्टूडेंट्स, वेलकम टू माय यूट्यूब चैनल शिव एकेडमी सोनीपत. And in today's video, I am going to discuss about different types of discontinuity. So, before starting about the types of discontinuity, let us discuss about the definition of continuous function. So, if you look at the screen, I have written the definition number 1. A function fx is said to be continuous at a point x equal to a. If there are three conditions, limit x approaching to a fx exists. The meaning of exist is here that the value must be finite and definite. And definite means to say unique. Means to say if you get the value finite and unique, then we say that limit x approaching to fx exists. Second one is f of a exists. Second condition is f of a exists. And third one is limit x approaching to a fx is equal to f of a. If all these three conditions are satisfied, then we say that the function fx is continuous at this particular point x equal to a. And one more thing, dear students, in the condition 1, we have written here limit x approaching to a fx exists. So now what is the meaning of limit x approaching to a fx exists? It means that there are two kinds of limits, LHL and RHL, means to say left hand limit and the right hand limit. If both these limits exist and are equal, so look at this note, limit x approaching to a exists if both LHL, that is limit x approaching to a minus fx, and RHL, limit x approaching to a plus f exists, and LHL is equal to RHL. And so what we write here, and LHL equal to RHL, then we say that these limits, the limit exists. So according to this, we can define the continuous function at a particular point. So now come to the second definition, which is a very important definition, epsilon delta definition. So a function fx is said to be continuous at a point x equal to a if for given epsilon greater than 0, there exists a delta greater than 0 depending upon both a and epsilon. So in the next videos, I will give some input of uniform continuity also. At that point, you will get the difference that why we are saying that this delta depends upon both a and epsilon. And the condition for continuity is mod fx minus fa less than epsilon whenever mod x minus a less than delta. So this is the epsilon delta definition, in which you have to remember that this delta depends upon both the point at which we are going to define the continuity and epsilon, which is absolutely very small positive value. And now what do you mean by left continuous? Because using all these conditions, we are going to define types of discontinuity. Just like if you look at this first slide, here we are having three conditions. If any of the one condition is not getting satisfied, then we say that function is discontinuous. So we will discuss further in this video. So left continuous means to say we are talking about just the left hand limit. So in this case, we say that a function fx is said to be left continuous at a point x equal to a if condition is slightly different from the continuity, because we are talking about the left continuity. So in this case, we are just talking about the left hand limit. That means to say, if left hand limit exists, f of a exists, and last but not least, limit x approaching to a minus fx is equal to f of a. And on the same way, we can define the right continuous function. In this case, we just replace LHL by RHL. So if RHL exists, f of a exists and limit x approaching to a fx is equal to f of a, then we say that function is right continuous. So that means to say, now it is clear that a function is continuous if it is left continuous as well as right continuous both. Then we can say that a function fx is continuous. Next thing is continuity and open interval. So in this slide we are going to define continuity in open interval, closed interval and discontinuous function. So when we talk about the open interval, you know very well that the endpoints are not included. So if the function is continuous at every point of that interval, then we say that function is continuous in that particular open interval AB. But what about continuity in closed interval? If you look at the second definition, continuity in closed interval, so what we do here, we take three cases: to the right of A in the open interval AB and to the left of B. So first thing is that function must be continuous at every point in this open interval AB and continuous at this A, but in the right of A, means to say right continuous at A and left continuous at B. After combining these three conditions, we can say that function is continuous in the closed interval AB, means to say right continuous at A, continuous in the open interval AB and left continuous at B. When we combine all these three, we can say that function is continuous in the closed interval AB. And just I discussed with you discontinuous function, that when we can say that a function f is discontinuous. So we can define if either LHL does not exist or RHL does not exist or both of them does not exist. And one more thing, LHL, RHL exist but they are not equal, then again we can say that function is discontinuous. And one more thing, when LHL, RHL exist, they are equal but not equal to f of a, means to say value of function at that point. So according to these, we are going to define now types of discontinuity. So now watch this screen. Types of discontinuity. In this case, we are taking f from A to R be any function. A is now any set, any non-empty set. So if you look at discontinuity of first kind. So discontinuity of first kind is what? If LHL and RHL both exist but are not equal. So I told you that we will take some cases of discontinuity according to the definition. So if LHL and RHL both exist but are not equal, that is LHL not equal to RHL, then f is said to have discontinuity of first kind. So here LHL, RHL both exist but they are not equal. So to understand the definition of first kind, look at this example. Consider the function fx equal to mod x by x, x not equal to 0, 1 if x is equal to 0. So here f0 is equal to 1, because at x equal to 0 we have written here fx equal to 1. Now compute the value of RHL and LHL. So if you compute RHL, you get limit x approaching to 0 plus fx. You put the value of fx from here when x is not equal to 0. So it is mod x upon x. So it is mod x upon x. But you know very well that from the definition of absolute value function, mod x equal to fx if x is greater than 0. So we replace this mod x by x in the numerator. So you get x upon x 1. So when you put the limit, so you get the answer 1. So RHL is 1. Similarly, you can compute this LHL, means to say left hand limit, means to say limit x approaching to 0 minus fx, which is limit x approaching to 0 minus again mod x by x. Again use the definition of absolute value function. So you get this mod x equal to minus x from it. So you put the value minus x, so you get minus x upon x, so x cancel, so you get minus 1. So in this case, LHL, RHL both exist because both are having finite and definite value, but they are not equal. That's why we say that it is the discontinuity of first kind. So dear students, in discontinuity of first kind, you have to remember the result that LHL, RHL both exist, but both are not equal. So it is the discontinuity of first kind. But if we look at the next type, discontinuity of second kind. So in this case, LHL or RHL or both of them do not exist. What I am saying that either LHL or RHL or both of them do not exist, then we say that this discontinuity is of second kind. So again look at the example. Consider the function fx equal to 2 raised to r1 by x when x is not equal to 0, 0 when x is equal to 0. So if you compute the RHL from here, limit x approaching to 0 plus fx, put the value of fx from here when x is not equal to 0, it is 2 raised to r 1 by x. So when you put the value of x here 0, so it is 2 raised to r 1 by 0, which becomes 2 raised to r infinity, that is infinity. So it does not exist. So we say that RHL does not exist. That means to say fx has discontinuity of second kind at x equal to 0. So there is a little bit difference from the first kind. In the first kind, LHL, RHL were existing, but in this case, LHL or RHL or both of them do not exist. Then the discontinuity is of second kind. So now come to the next type. Next type I have taken here removable discontinuity. So in removable discontinuity, what we say that if limit now exists, but not equal to fa. Limit exists but not equal to fa. Then we say that function f has removable discontinuity at x equal to a. Again, for the explanation, I have taken this example. Consider the function fx equal to sin x by x when x is not equal to 0, 2 when x is equal to 0. So you can look here that f0 is equal to 2. And when you compute the limit x approaching to 0 fx, you get the answer 1 because it is the standard limit. Limit x approaching to 0 sin x by x. You can compute it by L'Hopital rule because if you solve this limit, you get 0 by 0, which is an indeterminate form. So you take the derivative of the numerator and derivative of the denominator. And when you simplify, you get the answer 1 here. And you can see clearly that f0 is equal to 2, but this limit is 1. So limit x approaching to 0 fx is not equal to f of 0. So fx has removable discontinuity at x equal to 0. So dear students, now what is the meaning of this removable discontinuity? Means to say now we define this function in another way, and if it is possible to define the function in another way such that function becomes continuous at that point, in that case only we can say that this point is having a continuity for the function. So that's why now we redefine the function. So how we redefine the function? Fx equal to sin x by x when x not equal to 0 and 1 when x equal to 0. So in this case you can see clearly that the limit x approaching to 0 fx equal to f of 0 because both are 1. That's why we can say that this function is now continuous at x equal to 0. So in this video I have discussed 3 types of discontinuity: first kind, second kind, removable discontinuity. In first kind I told you that LHL and RHL both exist. LHL and RHL both exist, but they are not equal. In the second kind, either RHL or HL or both of them do not exist, and in removable discontinuity, limit exists but not equal to f of a. So dear students, I think you enjoy the video. So thanks for watching the video. Please like, share, subscribe to my channel and have a good time. Thank you for watching the video again. Thanks a lot.